Good morning or good afternoon, good evening. I don't know what time the different people are at, but thank you very much for your introduction. And like Mr. Majira said, my name is James Oguttu. My training, I did training as my undergraduate was in veterinary medicine. I then specialized in veterinary public health and epidemiology. Yes, so you are all welcome to this presentation. I hope you'll find it informative and helpful. Just as a way of getting started, is what I hope we'll achieve out of this is that you'll be able to at least demonstrate an understanding of the basics of quantitative research and be able to name and describe the two main levels of statistical analysis that we normally use in quantitative research methods. I'm not going to go into the details of the analysis, but I'll just point out the two levels and then probably provide indicators of what you should do if you need to take this further. So my presentation is not actually very long. We're just going to basically look at what research is, the different types of research, and then we'll then zero down on the aspects of the research plan for quantitative methods. So let's begin by defining what is research. It's a systematic and unbiased way of solving problems. And this is by answering questions or supporting a hypothesis through generating verifiable data. So what we mean when we say it's a systematic process or a systematic method, it means it's a procedure for doing things that can be explained to others. In other words, it is not a haphazard method. It has to be done in a way that can be explained. If you cannot explain to others, then it becomes difficult to understand what you've done or even to evaluate your research. And it has to be built on existing knowledge. It's not just that comes from nowhere. It has to be built within what we already know. So in other words, in you doing research, you're just building onto the knowledge that is there and in the process building new knowledge. Research methods can be split into two broad categories, quantitative and qualitative research methods. And the method you'll use depends on your choice, on your research question. Let me say. Say, for example, if you want to look at how many people in your village have ever been bitten by a dog, you're not going to go for the qualitative method. You're obviously going to choose the quantitative approach. But if you want to look at why do people not go for immediate treatment after they've been bitten by a dog, you probably go for qualitative, but the quantitative can also answer that research question. So your choice also depends on your underlying philosophy of research and of course your preferences and the skills. If you've been trained in, like me, quantitative research methods, you'll probably lean towards the quantitative research method approach. So why do we use research to solve problems? This is a very important question, which unfortunately we do not always ask. Okay. Because there are various ways that we can solve problems, and these we can rely on authority. For example, like parents will help us to understand issues, problems that we have in life, supervisors, could be police, and so on. Sometimes we rely on personal experience. What happened when I tried to do this before? And that helps you to understand or solve problems. Or sometimes we just apply common sense or simple logic. Revelation is another way we use. We rely on what God tells you, or intuition. We rely on my instincts or feelings. And for example, let's have a look at some of these problems. Should I cross the road at a specific place where there is no pedestrian crossing? How would you solve that problem? Maybe the police would advise you. Okay. what should the South African government do to reduce the number of people dying due to rabies? Maybe your supervisor would help you solve that problem. But the issue is with these methods is that they don't usually provide us with the proper solutions to problems, and that is why we then resort to research. For example, like in the case of where should I be able to cross a road? If you actually did research, you could easily find out how many cars pass in the place, how long will you take for you to wait before you actually get a chance to cross, and you therefore make a decision that is informed based on what you have found. So having said that, let me look at qualitative research just as a way of introduction. I'm not going to dwell much. The presentation is more on quantitative research methods. But I just thought I should lay a bit of background on qualitative research before we move into quantitative research methods. So qualitative research is basically any research which does not involve numbers or numerical data. It will involve words or language, but it may also involve the use of pictures or photographs and observations. Almost any phenomena can be explained in a qualitative way. There is no research that you cannot do using qualitative methods. It is quite versatile. You can use it in any field, and because of that, it's actually the preferred method of investigation in countries like the UK and the rest of Europe. On the contrary, the Americans tend to love quantitative methods more than the qualitative approach. So it is not that any method is superior to the other. No, it's just your preference. Each of the methods will give you rich data that will give you an in-depth understanding of whatever phenomena you are investigating. And qualitative research is particularly useful when you're exploring things like how and why things happen. As we'll see later, that is not the strong point of some aspects of quantitative research. However, like every research approach, qualitative research methods have also got weaknesses, and I'll list here some of them. For example, if respondents do not see a value for them in your research, they may provide inaccurate, false information. Also say what they think the researcher wishes to hear, and that we end up with the spurious results. So when you're conducting qualitative research methods, you therefore need to take time to build relationships. Yes, hello?
Agenda is item 7.
Mr. Majid, is anybody saying something?
Sorry, I think it was Prof. Mbata, but I muted there. You can continue, Prof.
Okay. So when you're conducting qualitative research, you need to take time to build relationships with your research subjects or respondents or participants, and you should always be aware of such problems. The other problem you'll get with qualitative research is the issue of ethics. Every research has got ethical issues, and the qualitative research particularly has got a problem of the researcher easily gets access to confidential information. And so it's important always to bear in mind that you must not do harm to your research subjects by virtue of you having access to some of the confidential information. The other problem the other weakness of qualitative research is that generally it's harder for qualitative research to remain apart. I mean, the researcher to remain apart from their work. You get so much involved with the people that if you're not careful, objectivity may get lost or may be compromised in the process. So it's therefore helpful to develop habits of reflecting on your part to make sure that you remain objective throughout the research process. So those are some of the weaknesses of qualitative research. And how do you obtain data for qualitative research? It is through interviews, which may be structured, semi-structured, or unstructured. You could do focus groups, or could use postcards. These are small scale written questionnaires that ask, for example, just a few questions that are focused for participants to respond to. So the other sources of data is the secondary data, which includes, this could be diaries or written accounts of past events or even company reports. And then the last source would be observations. So I'll now move into actually the focus for today. I'll begin by defining quantitative research methods. So unlike our counterparts in qualitative research, we in quantitative research focus on gathering numerical data and generalizing it across groups or to explain a particular phenomenon. So the emphasis in quantitative methods is to carry out measurements and conduct a statistical or mathematical or numerical analysis of data, which we collect through polls, questionnaires, surveys, or by manipulating pre-existing statistical data using computational techniques. So in brief, quantitative research method is basically about manipulating numbers and to make generalizations about groups or to explain any phenomena that you're investigating. So what we do ultimately what we're aiming at in conducting quantitative research is we want to determine the relationship between one thing, which is the independent variable, and I'll get into that a bit later, and another, which is the dependent variable or the outcome within a population. So ultimately, that's what we're driving to when we conduct quantitative research. For example, like I've got a student currently who is doing a study on factors that are associated with the vaccination of dogs. She's looking at the village where she comes from, and she's looking at why would the people vaccinate and why do people not vaccinate? What factors will influence? Is it that if you're educated, you're likely to vaccinate? So in which case the education level of the person is the independent variable, and then vaccination is the dependent variable. So she's looking at the relationship between, she's also looking at the gender. If a house is headed by a female, are they likely to vaccinate their dogs as compared to a household that's headed by a male? What about age? If a household has got young household heads, are they more likely to have their dogs vaccinated? So that's what she's looking at. So she's gone out with a questionnaire and she's asked them questions. Do you have is your dog vaccinated? Yes and no, as the dependent variable. And then she has collected all the other factors like the age, who heads the home, how many children are in the home, how many animals do they have, things like that. So she's investigating the relationship between those. So what are some of the characteristics of quantitative research? Data is usually gathered using structured research instruments, and mainly we use questionnaires, but we can also use checklists. And results are based on a larger sample size, which is representative of the population. In other words, like I'll explain, I think I explained a bit later on as we go on, is that if you wanted to study a phenomena in a population, you cannot go examining every single person in the population. So what do? You look for, you get a sample out of the population you want and make sure that that sample is representative of the population. So that whatever you see in the sample tells you what is most likely happening in the larger population. That's the whole essence of sampling and making sure that the sample is representative. But we'll discuss that later on into the presentation. So the other thing about quantitative research method is it normally they have, we can be able to replicate or repeat it. And this is one key thing when your study is being assessed. If your study can't be replicated, then you have no study. I should be able to take your proposal, go out there and conduct the research without having to consult you. If you develop such a proposal, then you have passed your proposal stage. So you just remember that it should be replicable. And normally the researcher has a very clearly defined research question to which he's seeking answers. Like I said in the example I gave you, one of my students who is looking at vaccination. So the question is, she first of all she had a couple of questions that she's trying to answer. The first is, what's the proportion of people that have got dogs that have their dogs vaccinated? That's one question that she's trying to answer. The other, then, what factors influence vaccination of dogs? That's the relationship I explained earlier. She's trying to investigate. So she's looking at the two. But when we get into the statistics, I'll explain that a little bit in more details. The other characteristics of quantitative research is that all aspects of the study are carefully designed before data is collected. You don't go collect data and then come up and say, okay, now I have this data, what do I do with it? Oh, it is telling me this and this. No. Everything has to be planned before you get out to collect any data. And then the other aspect of quantitative research is that data are organized in form of numbers, statistics. They are summarized and then presented as tables, charts, figures, or other non-textual forms. I will explain this also later when we come to the presentation of data and quantitative research. So the other aspect of quantitative research is that the projects can be used to generalize concepts more widely. You can even use the results you have to predict future results or to investigate the possibility of causal relationships. But like I said, I'll go into more details later. We can infer that there could be a causal relationship using quantitative methods, but we cannot determine causal relationships, especially in observational studies. In experimental study designs, yes, we can establish causal relationships, but we'll get into that as we get along. So in quantitative research methods, we use tools such as questionnaires or computer software to collect numerical data. Just like qualitative research has also got its limitations and disadvantages. So the main advantages are findings can be generalized to a specific population. Like, for example, the study I've given about this student, she will be able to generalize it to the village. If out of the sample that she's collected, she finds that only 20% vaccinate, she can then say that only 20% of the people in that village, that's what we mean by generalization, all the 20% of the people in that village have their dogs vaccinated. So it gives us an idea of the level of vaccination coverage in the area. Say if the study had been on teenage pregnancy, she went into the village, collected the sample that's representative of the village, and then determined that maybe 5% of the teenagers in that village get pregnant at one time. So she can then extend and say from her sample, if out of her sample, 5% were pregnant, she can generalize and say in the whole village, about 5% of the teenagers are pregnant. So that gives you an idea of what is going on in the wider population. That's what we mean by generalization to a specific population. But she cannot now say the whole of South Africa. If she got in her sample, she got 5%, she cannot say that 5% applies to the whole of South Africa because she didn't study the whole of South Africa. She only studied her village, and that is where she took the representative sample from. If she wants to generalize to the whole country, then she will have to get a representative sample from the whole country. And based on what she finds from that sample, she can generalize to the rest of the country. So the other advantage that quantitative research has, the data sets are large and the findings are therefore representative of the population, like I've just explained. And then documentation regarding the research framework and methods can be shared and replicated. I mentioned this earlier on. The main thing when your proposal or your research is assessed is your research framework. Can it be replicated? Is it understandable? Can I get your scientific paper and I go out and do exactly the same research that you did and get the same results? If I got your proposal, can I go out there and without me having to consult you, replicate your study and do it exactly as you would have done it? That's the advantage of quantitative research. And because because the approaches we use are standardized, so it is very easy to replicate. 10 years even from now, I can still go back and do a study which was done 20 years ago. And why? Because the approaches are standardized. And then the limitation of quantitative research, it does not provide evidence for why. It's difficult to establish why people think, feel, or act in certain ways, which qualitative research is able to do. And the other limitation is that some groups may not be very easy to reach. As we will discuss later, depending on the methods you use. For example, like if you choose to collect data using the telephone interviews, it means that people who don't have telephones will not be reached. And if you use telephones, if you're using landlines, in the era of cell phones, these days people have got landlines. So it means that you're leaving out a number of people out of your research. So those are some of the weaknesses of quantitative research. And sometimes the studies can be very consuming and require a lot of time to collect the data. So I'll now move into quantitative research plan. I'm just going to give an outline of what a quantitative research plan entails. But I'm not going to cover every single thing. Some of these issues are better covered in separate workshops. They are just a workshop of their own. And so any quantitative research plan will include the following: literature review, which tells us what has been done. And in the process, identify where the gap that you're trying to identify lays, or what the contribution of your study is going to be. It will include the research design, which is an overview of the methodological decisions that you're going to take, the sample and the population that are involved, and then operationalization, which in my view is just basically what will appear in your proposal or in your scientific paper as the methodology. So data collection will be the other section that is involved, that is included in the research plan. How are you going to collect your data? Data analysis. How are you going to process? Which quantitative methods are you going to use? When you get your results, how are you going to display them? And after you've got your results, how are you going to interpret them or make sense of the findings? And of course, a timetable and the different tasks that are going to be done when and where. And then dissemination, where you're going to publish your results. It will also include other things like draft instruments, what I call draft instruments here. These are like your cover letters, the consent forms, drafts of the consent form that your participants have to fill. Ethical approval. You need ethical approval before you go out. So, and of course, bibliography. In this era of computer, and I suggest that you teach yourself on how to use Mendeley Reference Manager. It is available free on the World Wide Web, and it's very easy to learn. I've never actually taught any of my students how to use it, but all my students use it. I just tell them, go to YouTube, look at videos on how to use Mendeley, and within 2-3 days, they have sent me a document. They have used Mendeley in managing their references. You should not be managing your references manually in this era and age. It is so time consuming and wastes your time unnecessarily. But when you use softwares like Mendeley, just at a click of a button, you can change the whole, how the references are cited and how they are listed in your bibliography. So for this presentation, I'm going to focus on research design. I'm going to look at sample and population, then a little bit on operationalization, and then the basics of data analysis and how to present your results. Analysis, so statistical analysis, I think, in my view, that's a complete workshop on its own that we cannot include in this presentation. But like I said, I'll introduce you to the basics. What are the main things that if you're doing your research, you know at least what to ask and say, okay, I'm looking for the association between this, and the statistician will be able to help you determine which statistical analysis you should adopt. So now let's get into the scientific or quantitative research scientific methods. What is a scientific method? An objective, logical, and systematic method of analysis of a phenomena devised to permit the accumulation of reliable knowledge. What's a phenomena? A phenomena is whatever you observe. It can be subjective, like attitudes. Actually, in that project that I cited earlier on, the student who's looking at rabies vaccination in her village, the other thing she's looking at attitudes and knowledge. So she's measuring what the attitudes are towards the disease. Or a phenomena can be objective, like time, weight, and as we'll discuss later when we briefly look at experimental site designs. For example, like if you were looking at, I've got another student who is looking at using yeast in supplementing broilers. So he's looking at if you feed broilers with yeast, do they gain more weight compared to those that are not fed? So the phenomena he's investigating here is the influence of yeast on weight gain, feed conversion, and things like that. And when we say it has to be objective, it is, you should evaluate a phenomena you should not involve you should put your passions aside, put your political views aside, your theological views aside, and all your ideological viewpoints should not influence your study. Say, for example, you think your political party is liked very much, and then you do a study and you find that actually it's not. So you don't manipulate, and because of your political affiliation, you want to change the results to suit what your political inclination is. No. So it has to be objective. It has completely be removed from your passions, your political affiliations, your religious beliefs. So a scientific process has to be logical. It does not have to be something that just we pick out of the sky. It has to be rational. It has to follow the rules of induction and deduction. And what do I mean by induction? Deduction is we where we move from the general to the specific, generate ways to test theories in new situations. And this is what mainly those who are involved in qualitative research do. They test theories in new situations. Okay. While induction is mainly actually is the approach we use in quantitative research. Observational studies, one of the main advantages of observational studies is that they lead to generation of new theories. Okay, and so in induction you're moving from specific to you look at, for example, like in the study I've just said, this student is going to come up with a theory that says, is going to suggest a theory that says that when you're educated, you're more likely to vaccinate your dog compared to those who are not educated or those who are quoting lower education. So in that able to so I'll now move into basic research designs for quantitative studies. When designing a quantitative research study, you have to decide whether it will be any of the two. Is it going to be observational or is it going to be experimental? And those are the two main branches of a quantitative research studies. I am more into observational studies. I rarely do experimental studies, but our colleagues in animal science, in plant science, tend to do more experimental studies than us. And why is it important to decide on the design? It determines the information that you're going to gather and how you're going to analyze that information and also how you're going to interpret it. So it's important from the onset for you to be able to tell, for you to tell from the onset what your study is going to be, what design you're going to adopt between the two. So let's look at observational study designs. Observational study designs are employed in fields such as epidemiology, social sciences, psychology, and statistics. And like I've indicated earlier on, they draw inferences from a sample to a population. Okay. And then the other thing is that what's quite important is that in observational studies, the independent variable is not under the control of the researcher. Going back to the example that I gave of vaccination of dogs against rabies, vaccination is the dependent variable. And then all the other demographic variables like age, gender, socioeconomic status, those are independent variables. The researcher does not control them. But as you will see when you look at experimental study designs, is the independent variable giving, if I may use the example for the study of the student who's using yeast, who is supplementing broilers with yeast. So including yeast, the levels of yeast are the independent variables. So he manipulates to some group he gives a certain level, say maybe 20 grams, another group is going to give them 30 grams, another group is going to give them 30 grams. That's what I mean by controlling the independent variable. In observation studies, we don't control independent variable. So examples of observational studies designs include cross-sectional studies. Okay. And I'm going to go into the details of this later on. Cohort study designs, case control study designs, and then longitudinal study designs. Those are the four main examples of observational study designs that you could adopt. Of course, the most commonly used are cross-sectional study designs. So let's look at a cross-sectional study design. What is a cross-sectional study design? It involves looking at the data from a population at one specific point in time. That's why it's called cross-section. Like in this particular case, in the case of the student who is doing a study on rabies, she's looking at the people who vaccinated their dogs at that particular time. That may change if you come 5 years later. It may have been different 5 years earlier, but she's only interested at that particular point in time that she's going to the community. That's what she's looking. That's why it's called a cross-section study. It's just like you're looking across the population at that particular point in time. A cross-section study design is a descriptive research, and it's not causal. It does not determine what the cause is. She will not be able to tell us what causes people not to vaccinate. No, she will not be able to tell us that. She will only be able to tell us that this number of people vaccinate, this number of people don't vaccinate. Among the males, more males vaccinate than females. Then she's going to look at who are likely to vaccinate, the association between, that I discussed earlier on, the association between the independent variables and the outcome. Okay. The cross-sectional study designs are also called cross-sectional analysis. You may find in some papers they are called transverse studies, or they are called prevalence studies in epidemiology. Like if she was looking at the number of people who have been bitten by dogs. So what she's looking at the prevalence of dog bites. So she'll go in and maybe collect a sample of 250 people, and out of those ask, have you ever been bitten by a dog? Some will say yes, others no. Then she will determine how many in the sample were bitten by dogs, and then use that to extrapolate that to the population and say in that population, the prevalence of dog bites is either low or very high, depending on what she finds. So we use cross-sectional study designs to determine how many animals, for example, are sick from a certain disease. Some features of cross-sectional study designs: the investigator measures the outcome and exposure in the study participants at the same time. Once again, falling back to the same study again. The student goes in, she's measuring the outcome. Is the dog vaccinated or not? And at the same time, she's measuring the exposure. The exposure is the same as the independent variable. She's measuring the gender, the age, education level, employed or not employed, and things like that. So you go into the community, and you measure both the outcome and exposure at the same time, as opposed to the experimental study designs, where you first administer the exposure, which is the independent variable. Like in the case of the yeast study, you determine what levels you want to feed the chicken. You feed them, then after a while you come back and measure the weight of the birds. So the two are measured at different levels, while in observational studies or in cross-sectional study designs, you measure the two up at the same time. And participants are based on the inclusion and exclusion criteria set for the study. Okay. So when you're determining, you want to go and look at the number of people who have vaccinated their dogs. You could decide to say that the inclusion criteria is going to be on the homes that have got dogs. And if somebody does not have a dog, they're not going to be included. That's what I mean by exclusion criteria. You have to determine who is going to qualify to be part of your study and who is not. If you're looking at teenage pregnancy, for example, you're not going to look at women who are not teenagers. So the inclusion criteria will be only girls who are between 15 and maybe 19. Those who are 20 and above, they're going to be excluded. So that's your exclusion criteria is going to be only people who are outside who are older than 19 will not be included. So you have to always have an inclusion and exclusion criteria for this study. So the next study we want to look at is the longitudinal study design. This, like the cross-sectional study design, is an observational study design, and it employs continuous repeated measures. Like in the case, I mean, if I can give the example of, can still use the same example of vaccination of dogs in this particular village. This student is going in once, because it's a cross-sectional study design. She's going in only once. And when I mean once, does not mean only one day. It may be from, she goes in April and collects data until May. We take that as one period. That's called a cross-sectional study. So she goes that, she collects all that data once between those 3 months and then goes and analyzes. Alternatively, she can go in this year, look at collected data. Okay, so she goes in this year, determines who she wants to study, or samples a few people that she is going to include in her study, collects data from those people this year, comes back next year, the same people, asks the same questions on the same people, comes back another third year, the same people, collects the same information from them, goes back, and that can go on for as long as you want. That's called a longitudinal study, as opposed to a cross-section, which you just go in once, collect information. It may be for 6 months, maybe for 5 months, it may be for a year, but you collect information once from each participant, and that is it. Okay. Also, like cross-sectional study, you don't interfere with the survey participants. You just go collect information on the different variables. I've indicated the last point I've mentioned. The researcher collects data from the same subjects of a long period of time, and that can be many, many years. So that is done in studies where they look at chronic conditions that take probably long to manifest. Say, for example, you want to look at, does maybe smoking cause cancer? You then get a group of people, and that's how it was done. You get a group of people that you follow year after year. You keep examining their health and see the effect of smoking on their lives. Or exposure, maybe people are exposed to certain things and you follow them through a long time to see. Or in any phenomenon that takes long to manifest. Or you just want to see how the community is changing over time. Like in this particular case, for example, she wants to see, actually the other objective that the student is investigating in that study is she's looking at the knowledge. She's looking at their knowledge of rabies. Maybe she wants to know if the knowledge level is changing over time. So this year she will go and say, okay, 50% of the people prove to be knowledgeable. The score is 60% and above in the test. If she comes next year, maybe the number will have gone up, because we are assuming that the Department of Agriculture and Rural Development is offering extension services and educating the community on the dangers of rabies and the importance of vaccination. So we assume that they're going to understand the disease with time. So she could keep coming in year after year to see if the knowledge level is changing or has remained the same, or has even gone down. Okay. The other one, study design, is a cohort study design. Here we have groups, and actually cohort just refers to groups that we follow prospectively. In other words, I've explained a bit like you can get two groups of people who smoke and those who don't smoke. And you follow them, those are the two groups are called cohorts. So you then follow those people over years and you see, is the cancer higher among those who smoke compared to those who don't smoke? If the answer is yes, then you can associate smoking with cancer. You may not be able to say that smoking causes cancer, but you're able to establish that there's a relationship. And once you establish a relationship, then we now can go ahead and and do further studies to establish whether smoking is the cause. So here what I'm saying is just that one or more samples or groups are followed prospectively and then subsequent status evaluated. The most important thing that I want you to pick out of cohort studies is that the participants have been exposed. They are normally chosen based on exposure. In other words, like I said, in this case, the exposure is smoking. The other group has not been exposed, they don't smoke. So we want to see if exposure to smoking will lead to cancer development. That's very important for you to remember when I discuss the next one, which is a case study. The criteria for inclusion is different from cohort. In cohort study, you're looking at participants who have been exposed. Say, for example, we come out and say, I don't know, which example can I give? Maybe drinking Cohort is, we've been told it can cause, because of the way it is made. I think I've seen some studies that suggested that it is associated with throat cancer. So we look at people who take this drink and those who don't. We get the two groups: those who have been exposed, and as they've been drinking it; those who have not been exposed, and as they haven't drunk. Then we follow them over a period of time and see which group is likely to develop throat cancer compared to the other. Okay, so the last point there, that investigators identify subjects at a point in time when they do not have the outcome of interest. In other words, they haven't developed the cancer is the outcome of interest, and then compare it to those who have not been exposed, as I've explained. Then the other quantitative research design is the case-controlled study design. In this study design, the researcher, in this study design, the researcher compares patients who have the disease or the outcome of interest with the patients who do not have the disease or outcome. Remember, in cohort we said you're interested in those who have been exposed. They don't have the disease, but they have been exposed. They don't have the outcome, but they have been exposed. And then you follow them to see if they will develop the outcome. In case control studies, it's the opposite. You want people who have the disease, and then you want to go backwards and see what led to the disease. Is there something they were exposed more than those that do not have the outcome? And that's how you establish the association. Okay. So while cohort studies are prospective, in case control studies are retrospective. They have already developed the outcome. They already have the cancer. So you get, say for example, we have many people in the community who have got throat cancer. We get those with the case, we get those who don't have. And then we look back, what is it that they have been exposed to in the past? If we find that those with cancer have been actually taking more of some dangerous substance, which this other group is not been exposed, then we can associate that thing is associated with the cancer that we are seeing in the community. Okay, and so that brings us to study designs. There's questions for you to ponder on. What are the similarities and differences between case control and the study design and cohort? Are there any similarities and differences between cross-section and longitudinal study design? And is there any difference between longitudinal study design and cohort study design? Would you be able to explain to me if I was to ask? Or would you be able to choose between these different study designs for your study? I presume yes now. So let's look at the experimental study design. Remember I said that quantitative research methods can broadly be divided into two: the observational study design and the experimental study design. We've just discussed the observational, which are cross-sectional, the longitudinal, the cohort, case control. Okay. And then we have the experimental study design. So here subjects are allocated to groups. I've given the example of if I use the example of this student who is looking at the impact of yeast, of supplementing broilers with yeast, he has about 4 groups. He has the control group that's not going to be treated at all. Then he has the group that receives the lowest level, 20 grams, the group that receives 30 grams into their feed, and a group that receives a higher dose. So he has the 4 groups. So he then gets the chickens and allocates them to the different groups. I've also got another student who is trying to come up with a protocol for treating horses. And actually, I was discussing with him yesterday. He's trying to come up with a protocol for treating horses using a new method. It uses shock waves to treat injuries in horses. And what I'm just saying is exactly what I told him, that he needs to make it very clear. How is he going to allocate horses to these different groups? It has to be done randomly. You don't look at a horse and say, oh, this one looks good, should be in group 1. This should be the control, this should be in treatment 2, treatment 3. No. You allocate the horses in numbers, then you just pick the numbers randomly and place them in the different groups. Okay. That's called randomization. And so the included subjects are measured before and after a particular treatment. In this particular case, all the groups, the weight is measured. Then after maybe 7 days, you come and weigh the groups again and see what changes are taking place. With experimental study designs, the sample population may be very small. You can find people using up to 20, 50 birds or 20, 50 cattle or sheep. Like I said, they're purposefully chosen, but mainly it is intended to establish causality between variables. In this particular case, it is intended in the example of yeast in broilers, is he wants to see how supplementing broilers with yeast impacts on weight gain, feed conversion, meat quality. So he's looking at does yeast actually impact on these variables. So experimental designs they provide a more accurate evidence compared to observation studies. So experimental study designs, there are quite many. I'm not going to go into the details of each. I just want to introduce you to them in case should you need to use them. But if you look at on my right, that picture, I've put a picture of 2 vehicles. One is the control, the other the experiment. See the control, nothing is done to it, and then the experimental group, it has been tampered with. So experimental designs, like I've said, there are many, as you see from that diagram. We have pre-experimental research designs. We have what we call the quasi-experimental research designs. They are almost something between experimental and observational. Why they are called quasi? So for example, like if you looked at, I'll just explain the quasi here, is that if you looked at if say you have 2 villages, and in one village you're having, I think I've got a friend who wanted to do that study, in one village you have, say, many children are having sequential nutrition deficiencies. In the other village, they are not. So you could then use the 2 villages. You could use the other one where they are not as a control, and this one where there are problems as the experimental group. That's why it is called a quasi-experimental design. It is not randomized. That's why it's called quasi. In the true experimental research design, you randomize, like I indicated earlier on. So having discussed study designs, let's now look at the population and samples. 2 populations that you'll deal with mainly. This is we have what we call the target population. This is the population of interest. For example, you want to study teenage pregnancy among girls in Pretoria. Your target population is all the teenagers in Gauteng. Sorry, it should be all the girls in Pretoria, not in Gauteng. But because you cannot reach all the girls in Pretoria, you are then going to select a sample that's representative of the girls, and then you're going to study that sample. So that sample now becomes your study population. And how do you sample it? It can be done randomly or non-randomly. And the problem if you involve non-random sampling is you can't test hypothesis on non-randomized. You cannot test for associations on non-randomized. You only limit yourself to descriptive analysis. I'll explain that a bit later, I think, as we get on. So I've indicated that you want to look at teenage pregnancy among girls in Pretoria. You can't get access to all. You cannot study because it will be so expensive. It will take you a lot of time to reach each and every girl. So what you do, you'll then get a sample. But most important, that sample must be representative. As if not representative, then you can't infer, you cannot try and generalize your results to all the girls. And what we mean by representativeness is it just means the extent to which the sample is similar to the population on the characteristics that you're measuring. Okay. So it is essential that if we wish to draw conclusions about a population-based sample, we need to make sure that the sample is representative. Very important. If your intention is to draw conclusions about, like in this case of the student who is studying rabies, if she wants to tell us about the situation in the village, she must make sure that the sample she drew from the village represents the village. If not, then she can't draw conclusions about the population in the village. So how do we ensure representativeness? The only way is by probability sampling. And what do we mean by probability sampling? Every person in the population has got an equal chance of being selected. And as you're not being biased in any way, you want to give everybody a chance to be selected. And we'll discuss how you can do that. So as also I've indicated that probability samples are required for hypothesis testing. And what do I mean by hypothesis testing is, for example, like if you want to test that, for example, that girls are more likely to score higher grades. That's the hypothesis. Or girls and boys, there's no difference in the grades between the girls and boys. That is your hypothesis. That's the null hypothesis. For you to be able to test that, you need a probability sample. If it is a conveniently selected, you can't test a hypothesis. And you can't use statistical models if your sample was not selected using probability sample, one of the probability sample methods. So how do we conduct probability sampling? That is our next section. Mr. Malaja, are we still okay?
Yeah, we're still okay, Prof.
Yes, good. So let's look at mechanisms of probability sampling. The first and the most easiest and the most commonly used is what we call simple random sampling. What does it mean? It means that all the units have an equal chance of being selected. For example, I've put up an image there. That is your population. For example, you have a population of 7 people. You allocate each of them a number. You put those numbers, you write those small numbers on pieces of paper. As we do raffles, you put them in a hat. Then you draw out 2, you draw out randomly. In this particular case, they drew out 2, drew 4, and 5. So that is going to form your sample. That's a random sample. That is simple random sampling. But like you can see, it is if you have a very large sample, if you have thousands of people, you can't do this. So if you've got very large samples, then simple random sampling becomes a little bit complicated. So there are different ways of conducting simple random sampling besides what I've just said, besides allocating them numbers, putting them in the hat. That is the easiest, and then you draw them up. You can use softwares. They can generate random numbers. You allocate numbers. You allocate them numbers, and then you use like Microsoft Excel can generate random numbers. Then it will just give you which numbers you should select. Then you got the population. It will give you maybe 2, 3, 1. Then you just go to the population. The people you have assigned those numbers are the ones that you select and include in your study, and they become your sample, your study sample. So the other probability sampling method is what we call cluster sampling. Here it involves sampling at 2 or more levels. For example, farms or herds. Say, for example, you have herds in the village. You could then use herds as clusters. You could call the herds clusters. So what you do is that if you have, say, 50 herds in the village and you want to study maybe the prevalence of any disease in the herds, you could select just a whole herd. That's called cluster sampling. You just select the whole cluster. So in this particular example here, we have cluster 1, 2, 3, 4, and 5. So the researcher selected cluster 3 and cluster 2 randomly. So you give each cluster a number, then randomly pick out the numbers. So this one picked out 2 and 3. Now with cluster sampling, that once you select the cluster, you then have to study all the participants or all the elements in that cluster. Very important, you remember that. When we move to stratified sampling, it's a little bit different. You also sample at different levels, but the approach is a bit different from cluster. With the cluster sampling, you just sample the clusters and then you study everybody within the cluster. So in a way, it also gives each individual the same chance of being selected. In other words, you're not being biased. You're not coming up with a certain criteria. You don't go looking for herds that you think have got more problems. Here, all the herds are put in the hat. You select out 2 herds, and those are the ones that you're going to study. And then we assume that they represent all the other herds in the area. So the other probability sampling method or approach is stratified sampling. So you sample within subgroups that are relatively homogeneous, so as to yield more precise results than a simple random sample. Say, for example, we have breeds. I don't know how many of you are familiar with cattle. Which example would that be? Maybe agreeable at all. So let me just use the example of humans. Everybody will know that. So, for example, you're looking at say high blood pressure. We know that sometimes high blood pressure in certain age groups, it is higher. The prevalence tends to be higher in males compared to females. So if you just go in and put all the males together and then determine the prevalence of how many people or the proportion of people with high blood pressure in that population, you may end up with a very low number. You may end up with a very low number. You may end up with a very low number, and the reason is being that because we know that in females the levels tend to be low. So if you combine them with males, it may bring the prevalence low. But if you decide to stratify them and say the females is one strata and the males is another strata, you then sample among the males and determine among the males how many. You may find that the prevalence is higher than what you got for the population when they were together. And then you look at the females as a different strata. you may find that the prevalence is lower than what you got for the general population. So here you have got, for example, with the first level, you have the first strata, then you have the second strata, the second, third, and fourth. So you select, then randomly you go into each strata and randomly select. And I think this is the, I'm trying to remember an example of one of my students was done, stratified random sampling. Okay, I'll remember an example, but I hope it's clear. Here you have stratas, you stratify, in others you put them into different layers. You have men on their own, then you randomly select out of the men. Then you have females on their own, then you randomly select out of females. It could be, those of you familiar with cattle, you could have herds, like the example used of clusters. Herds, you have got different herds. So you go into the herds are clusters. So in each herd, you go and randomly select a few from each of the different strata. That's stratified random sampling. Then we have what we call systematic sampling. This is we use this when we have very large samples. We don't know the total number of animals. And those of us in animal science, and we use this at abattoirs of deep tanks. Say, for example, the whole village is bringing animals to the deep tank. It will be difficult for you to randomly select animals. So what you do, in that case, systematic random sampling is the best. With systematic random sampling is you determine the interval that you're going to use. In the diagram that I provided there, they are selecting every fourth house. But the trick with the systematic random sampling is how do you determine the first house? There are formulas that we use to determine the interval, and that is based on the population and the sample size that you're going to use. I'm not going to go into details of that, but when you are planning and you think systematic random sampling is the best, then approach a statistician. He will advise you on the sampling interval to use. But what you do is that the first house is selected randomly. Say, for example, like in this case, it is the every fourth house, that is the interval. So you choose the first four are chosen randomly. The first four are given a random number, are given numbers, put in the hat, and then you choose out one. In this particular case, they chose house number 2 out of the first 4. So that was the first house to be sampled. Then from there, every fourth house was sampled until they got the sample size that they wanted. If it is in deep tanks, the same. The first animal selected randomly, then maybe every 50th animal. So you leave 49 to pass, the 50th you sample it. 49 to pass, the 50th you sample it. If it is a deep tanks. In the abattoir, the same. If the animals are coming out online, those of you who are familiar with abattoirs, it's the same. And this student of mine that I'm saying, who is doing a study on vaccination of rabies, actually used systematic random sampling. Okay, the other one is network sampling. Those of you who are into qualitative research methods, you would be familiar with what we call snowball sampling. It's almost the same concept, if not the same. But this is we use this when you do not know, you don't have what we call a sample frame. You don't even know where the elements or the people you want to study are located. Say the best example is like drug addicts. You will not know where they are, but they will know themselves. So you identify one, and that one will tell you where the other one is. That one will tell you where the other one is. That one will tell you where the other one is. So you then follow. That's called network sampling. So you could decide to establish the network and then randomly sample out of that network to make it more random. I've used snowball sampling in some of my studies. What I did is that because the studies I've done where the population is small, is I studied everybody. So I try to do as much as possible to make sure that I reach every single person that they could help me identify. So that's called network sampling. So we use it where we do not know where to find the people that we want to study. But we assume that there's a link between them, or there's a sort of a network between them. And that is, it's commonly used when studying drug addicts and drug abuse, or people who are using drugs. So in this particular case, person 1 was the first one to be identified. He identified person 2 identified person 3 identified 4 and 7, then 4 identified 5 and 8 and 9, 8 identified 9, like that. So what this indicates that then after establishing the network, this person then randomly selected, and randomly selected P using simple random sampling, selected P to 7, 4, and 10. Those are the ones that he studied. You can do it that way, or if there are not so many, like in this particular case, if it was me, I would just do all of them. The other one is distance sampling, also called transect sampling. It is used a lot of those who are in plant science. I've not used it before, but you draw. Also used in, it's also used in assessing the population of animals, say in a game reserve. You draw lines across the game reserve, drive along that game, and you keep counting the number of animals that you're seeing. Or you can cut off certain areas. What do we call them? You can draw off. You can divide the area, subdivide the area, and then go into those areas and count whatever you see in there. So in this particular case here, you can see the person is standing on the line on the transect. He's able to see some animals. Those which are behind he can't see, so he's only going to count 1, 2, and 3. The others he can't see. Then he will move certain place, count 1, 2, 3. And that's how they establish the number of animals in a certain area. It's also used by those who study plants. If you don't know how many plant species in an area, you can use transects. Okay, so you know how to sample, you know how to get your random sample, but now the question still remains: how many people, how many animals should I sample? You need always a large enough sample size to give you enough statistical power for you to be able to reach a reliable conclusion. So the issue then, what is large enough sample size? There's an interesting discussion in that image there. If you look at the bottom here, this guy is asking, we need to determine the sample size for the product test. So the question is, how confident and precise do you want the results to be? That's an important question to ask yourself. How should the results, how confident you want to be? That if I say that that men are more likely to vaccinate their dogs compared to females, how confident am I? So this one says, I want to be 100% confident. Normally we use 95% confidence. Okay. And then the next question is, which margin of error we would need a very big sample size to be 100% certain? So the more confidence you want, like if you want to be 100% confident, 99% confident, then you need a very large sample size. But if your confidence level is very low, you need a smaller sample size. Okay. So when choosing a sample size for the study design, you have to consider the sampling error. That's what we call the margin. What margin of error do you want to allow? To what extent would you allow to be wrong, in other words? So my personal view is that I will not go into details of how to determine sample size, but consult a statistician or an epidemiologist, or you can use sampling tables if you know the population of the area that you're going to study. Okay. And you should do this at the beginning. Do this right from the very onset. Don't come and try to consult on what sample size you need after you've already collected the data. Sometimes you end up with very few, and then you can't do any statistics on the data that you have. And then you've wasted time, you've wasted money, and it's unethical. So before you get started, consult a statistician and discuss with him. I want to be 95% confident. We normally use 95% confidence and want to allow for a margin of error of 5%. That's the most we commonly use. I said you can use statistical tables. This is an example of statistical table or sampling table required. These tables have worked the sampling error and the margin of error and the confidence into them. If you see, I don't know if you can see the blue one. This person wanted a sample. He has a population of 5,000. That's the village, wherever he's going to study, has a population of 500 households. So he wants to determine how many households should he sample. And he wants to be 95% confident, and he's allowing for 2.5 error. So the table says he can select up to 1,176. But if he wanted to be 99% confident at the same margin of error, he would need 1,734. But if the population was 200, he wants to be 95% confident and allowing a margin error of 5%, 200, a sample of 200 will give him 132. So that is how to determine the sample. That's the easiest way. Use sampling tables. There are quite a number of them available on the net. Okay. Operationalization of quantitative research. This is, like I said in the beginning, this is basically to do with this is what you call your research methods. And if we get time, I will probably show you an article of one of my students who was in the process of being published, where he does the things that I'm mentioning here. Describe the measuring instrument. For example, you want to know how many people vaccinated their dogs. What instrument are you going to use? The questionnaire. The concept you're testing is the proportion of people or vaccination coverage. What measuring instrument are you going to use? You're going to use a questionnaire. And describe how was the questionnaire pre-tested. Never ever make a mistake of going to collect data without pre-testing. If you've designed a questionnaire, and I think that's a workshop of its own. I think the department does offer a workshop on questionnaire design, and I think this is discussed there. But once you've decided you're going to use a questionnaire, before you go out, first go select people that are almost similar to what you're going to study and test it on them to make sure that the questions are easy to answer, are understandable, they are not confusing. Before you finally go and say, I've got a student who did that. He decided before I knew it, he had already gone out to collect data. So when he brought in the data, fortunately, he just done a few, which we then used as a pretest. We looked at the questions, and most of the questions were being misunderstood. It was not giving us the kind of questions the kind of answer that we were looking for. Okay, so that is pretesting is very important. That ensures that your instrument is going to measure what you want. It's going to collect the data that you want. If you don't, you just design it in your office, and next thing, boom, you're out in the field testing. You'll be very disappointed when you bring the data back to your office and you want to begin capturing it and realize there are so many gaps, some things that were misunderstood, some questions where the answers were given are not even relevant. You can't use that question anymore. Very important. Make sure you pretest the instrument. I cannot overemphasize that. If you ever do it, you'll be in huge trouble. And then there are also statistical methods of testing reliability and validity of your instrument. That's also another workshop of its own that I think you'll be exposed to, or you've been exposed to, I'm not sure. So you have decided that you're going to use the questionnaire. How are you going to administer the questionnaire? There are various ways. You can do by telephone interviews, you can do face-to-face interviews, you can email them, you can use checklists and do observation and just tick off the checklists. Each of these methods have got the advantages and disadvantages, and I think I mentioned this earlier. For example, if you use telephone, you're likely to miss people who don't have phones. If you do face-to-face, sometimes you go and people are not there. You have to come back. How many times must you come back before you eliminate that person? Those are some of the issues. Okay. So what types of data the types of data in quantitative research, depending on when it was collected, it could be primary data that you go out and collect prospectively, that's called primary data, or it could be secondary data. Secondary data is data which is already there. Okay, for example, like a lot of government departments collect data. We have just written an article and used data which was collected by the Department of Housing. They do surveys every 2 years on residents of Gauteng. So we were looking at, actually there's one that we're writing with a colleague, we're looking at gardening in Gauteng. So fortunately in that data set, they asked the respondents whether they have a garden. And so they said yes or no. And then there are other variables, the education level, the agenda, there are a lot of other independent variables that are in. So we are now looking at what factors influence gardening in Gauteng. So we're using secondary data. We didn't go out to collect. It's data which is there. In hospitals, they collect all sorts of data. If any of you who are interested in hospital, what? So it's data which is there. Statistics SA collects lots and lots of data. You can access, you can approach them and request for data. They will give it to you. And there are very many other organizations that, even internationally, collect data that is available for that you can use for your study. You don't always have to go to the field to look for data. So when you collect data, actually, data is made up of variables. So variables are just, what are they called variables? These are factors or traits or conditions that can change. For example, like gender is a variable. One may be male or a female or other. Education, one may be not educated, stopped at primary, completed secondary school, has a tertiary institution, tertiary qualification. Those are that's a variable. It varies. That's why it's called a variable. So gender is a variable, and that's the data you're going to collect. So when you collect data, there are two kinds of variables. There's what we call the independent variable and the dependent, and I've kept hinting on this. The independent variable doesn't change. The dependent variable changes depending on the independent. For example, high blood pressure. Like I said, will change between male and females. We know that in young ages, it tends to be high among males. As in older ages, it's almost the same. Okay. The disease prevalence, it varies from country to country. So the variable that changes is sometimes also called the outcome. While the one that doesn't change is also called at times called exposure, as I indicated a bit earlier on. Okay. So in experimental studies, the independent variable is the one the experimenter controls. Like I indicated in the case of yeast, the levels of yeast are controlled by the experimenter. Okay. The dependent variable depends on the levels of yeast. In others, do the chickens that receive 20 grams as supplement gain more weight compared to the control group and compared to those that receive higher levels or not? Okay. And then there's what we call levels of measurement. This I think you'll discuss if you ever get to do a workshop on data analysis and data capturing. These variables are measured at different levels. We have nominal. Okay. Let me say your variable can be classified as qualitative or quantitative. And in the qualitative, you have what we call the nominal and ordinal variables, while in the quantitative, we have what we call the interval and the ratio. Other books put it the other way. The variables are classified as categorical and what quantitative. Then under quantitative, you have discrete and continuous. Where the discrete is the count data, like number of animals. There are 5 animals, 10 animals, that is discrete. There are 5 boys in the class, 6 girls in the class, that is discrete. While continuous is variables like weight. It can be anything from 0 to any number. Okay. Then you have categorical, which is nominal, and nominal don't have any order. Things like male, female, that's nominal. Yes, no. While ordinal, those have got order. Then, for example, high school, primary school, one is lower than the other. Those are ordinal variables. So this is important, especially when you're capturing. You want to indicate which, like if you're capturing in softwares like SPSS, it requires you to classify at what level are you measuring the variable. Is it a nominal variable? Is it an ordinal variable? Is it an interval or ratio? Ratio scale. Okay, I think I'll leave that at that. I'm sure you will go into this when you in other workshops probably. So, how are we doing, Mr. Majila? Should I continue?
Yes, we can continue. There's discussion and number of questions.
Okay. Okay, I think I'll stop somewhere. I have somewhere where I've put a break again. Then we can go into the questions.
Okay, thanks, Prof.
Okay. So, what do we mean by analysis? Analysis simply means processing and summarizing information. You don't report raw data. Whatever data you could get from the field, it has to be processed, summarized, and before it is presented. You don't present your raw data. You just don't go and present in this village. There was one man, there was another man here, there was another female there. No, you have to process, compute proportions that we'll discuss shortly. So in quantitative analysis, we've got 2 main levels of analysis. There's what we call descriptive analysis or descriptive statistics. These are simple statistics which just provide a description of study population. Other people refer it as data visualization. It's like you're visualizing, you're just looking at your data. How many men do I have in my data? How many females do I have in my data? How many people do I have in the different age categories, 0 to 18 or 18 to 35, 36 to 49, 52. I mean, you're just basically describing your data or visualizing your data. You're just seeing what is in the data. There's not much that you get out of it. It just tells us things like population size, what's the unemployment, how many unemployed, how many are employed. Okay, this is the kind of statistics that is done by statistics SA. Their data is mainly descriptive. Okay, but when you're doing research, we use higher levels of research. We don't stop at descriptive. We want to go a little bit more and explore and explain associations and make inferences. Okay. We in experimental research, we want to establish causality. We want to, for sure, to say that if a bird is fed 2 grams of yeast, the mean weight gain will be significantly higher than the control group that did not receive. So in that case, we know yeast improves weight gain. So we then continue. I think we're almost coming towards the end. We then look at the levels of analysis, just the different I just mentioned. Now let's go into the details of each. Like I said, at this point, I'm only just giving a broad overview of the statistical analysis and how the data is presented. I'm not going to go into how do you exactly do it. So the first level is descriptive, also called exploratory statistics. And like I said, with the descriptive statistics is basically you visualize it. Just other people also refer to it as data visualization. You're just looking at your data. Like in this case, you can see they were looking. This is a study that was done on comedies. Do comedies get higher ratings than action movies? So they did a box plot, and they say you can see that action movies have a median of about just above 5 rating, while the comedies have got a rating of, the median is about 6. So this is just, they're just looking at how many people how this is rated, and yeah, I think those who rated action movies, those who rated at this level, those who rated at this level, those are the proportions. Yeah. So like I said, it just tells us about the population size, how many men are there, how many unemployed, how many females are there, how many old people are in there, well, how many people rated this way, how many rated that way. That is basically what descriptive statistics tells you. So it's always important when you've got your data, do descriptives. Just to run and tell us if you, on all the variables, I collected information on gender, how many men were there, how many females were there. I collected information on how many people consider themselves sick and how many consider themselves healthy. I collected data on the variable age, and the age had 4 levels, 18 to 35, 36 to 49, 52, and how many people were in each of those categories. That's just, you're just describing your data. There are different ways to do it, if also depending on the question that you're asking. I'll give an example. For example, like there was a study I was doing on people who were looking at self-rated health, how people rate themselves in Gauteng, using the same data that I said from the Department of Gauteng Provincial Government. They do a study, it's called Quality of Life. So it's a they do it every 2 years. So in that data, there's a question also that they asked, how do you rate your health in the past week? So people say very good, good, poor, and very poor. So we then recategorized it and made good. If they said good and very good, we say it is good health. If they said poor and very poor, we made it poor health. So we then looked at when we did the descriptives, instead of saying how many males are in this data, how many females are in this data, we said how many males reported good health, how many males reported poor health, how many females reported good health, how many reported. We looked at education. Are those who are educated with degrees tend to report more? How many reported good health, how many reported poor? Those who finished primary, how many? With like that, that's how we did the descriptive for that paper. So in brief, what I'm just saying is you run descriptive and basically just to visualize, just to describe that in my data, this is what is in my data according to different variables. You're not looking at, you're not trying to explain anything. Okay, but when you do research, if you're doing research, you don't stop at that. You then have to move to the next level and look at associations. Okay. So the other level is what we call the explanatory statistics, or inferential, as the word says. It tries to infer. It is, you're trying now to say, you're trying to say men are more likely. You're now looking at what's the chance that a man will have his dog vaccinated compared to the female. What's the chances that older people will tend to vaccinate their dogs compared to the young ones? Maybe families that have got more children tend to vaccinate those that don't have, because they fear that their children may be bitten by dogs. So that's now the kind of level we're talking about. We're trying to understand why things happen. We're trying to ask what is the association between things. Okay. We can then use statistical models. I mean, here we use statistical models, okay, or we can use predictive models. We can even try to predict what is going to come. If the population is growing at this rate, 5 years from now, what is going to be the population that we're trying to predict? So that's the next level. That's what we call inferential or explanatory statistics. If we get the opportunity towards the end, I can flash a paper and then one of our papers, and I take you through it and show you what we did for descriptives and what we did for inferential or explanatory statistics. So just what I want you to remember, what I want you to take out of this is that when you've collected your data, you explore the data. As that diagram shows, you explore the data, what is in there, and then you explain to the reader what do your results mean. Those are the two things that I want you to take out of this. Then as we come towards the end is the presentation of results. So you have done your analysis. How do you present your results? Like I said, you've run your descriptive analysis. How do you present it? You summarize and then present them as graphs if you have categorical variables. We talked about categorical variables, which you have male and female. How many males are in there? You have how many females are in there? You can draw a pie chart, or what they call a circle graph, or you have age groups, 18 to 35, 36 to 50, 51 to 64. So you want to say how many males are in each of those categories, how many females. You can do a bar graph. Okay. And then, so if you have mainly, for categorical variable, that's why I say that it's important for you to know at what level your variable is measured. If it is categorical variable, then you're thinking in terms of summarizing and presenting it as graphs or tables. In tables, you represent percentages and frequencies, or proportions and frequencies. But if your data is measured at a numerical level, it's a continuous variable for that matter, you then want to calculate the mean or the mode or the median. How do you determine whether to present the mean or median? It depends on the nature of your data. And that is something you'll cover in statistics. Because if the data, like we run what we call a normality test. If the data is normally distributed, then we report the mean. But if it's not normally distributed, we report the median. And so the mean from your primary and high school mathematics, you'll know the mean is just the average. Say you went in to collect data and you collected age as a continuous variable. You were asking the respondents, how old are you? It's 40, I'm 50, I'm 35, I'm 20, I'm 18, I'm 70. So you come and then you calculate the mean. If the data is normally distributed, you calculate the average. But if it is not distributed, you calculate the median age. But that is something you will cover in statistics. Mode is just what is the most common age group. Okay. If you look at that frequency table, you will see that these 1 to 15 had 18 people. So that is the mode. That's the most frequent age group. But if you have them in numbers 1, I'm 18, I'm 18, I'm 15, I'm 20. 18 appears more times, so it is the mode, the one that appears. The easiest way to remember it, mode has to do with fashion or modern. What is in fashion is the most common. So mode will be the most common. So when you report the continuous or numerical variables, you also always indicate the deviation or the spread to show you how your data is spread. By reporting the variance or standard deviation or the interquartile range. Those are things that you cover when you do a statistics workshop. Okay. Numerical data can also be presented as leaf plot. This is the leaf plot. Okay. And then you have this is the box and the whisker plot. This is used for categorical variables, and it reports the median. This middle number is somewhere. I just want to go back to the previous year. This is the box plot, and these are the whiskers. So that's why it's called the box and whisker plot. So when you have boxer plots for categorical variables like this one, these are two categorical variables: action and comedy. Okay, that is. So for this, it is showing the median was here. For this one, shows the median is here, and then the range, the lowest was here, the highest was here. This one, the lowest was here, the highest is here. Okay. And then it shows your interquartile range. So you can report using box and whisker plots or frequency tables or bar graphs, histograms. Line graphs can also be used for continuous variables. Say, for example, I'm sure you've seen this when they report the value of the rand, how it has been falling or how it has been gaining. You will see it, you can plot it over over months and see how it went up and came down. Okay. And I think that brings me to the end of this presentation.